Hello and welcome to my video where I will be explaining my first Handin for the programming course. So let's get started. In the first two lines we can see that we need to include certain libraries for us to be able to use commands from those libraries without having to explicitly mention that in every single line where we use them. The second line will be especially useful when we are trying to see what the size of certain variable is. Then we continue to actually get to the program itself. Our first task was to create 10 variables of different data types. In each of those variables we should store some value. The values should be stored in a way that they are always stored in the smallest data type possible, thus saving space. Here we can see the 10 variables. We have a short integer, unsigned short integer, integer, unsigned integer, signed char, unsigned char, float, double, long integer, and a boolean. The next task was to trace the variables to the command window. That was easily done by using the command out command. So we can see that the result for this trace is going to be value for variable 1 is, and then the value of the variable continued by a breakpoint, which means that the next line will be printed on a different line. This we repeat for all of the 10 variables we have. This line of the code is just like a line for visual separation, so when we actually see the program running, it's easier for us to read what's going on. The next task was to see what the size of certain variables is. We will use the size of command for that to see what the size of the variable is in bytes, which we will later convert to the size in bits, which is very easily done by just multiplying the previous value by 8. In these cases, the result which we'll see in the window will be the size of variable 1 is, then we will see what the size is in bytes, and then we will see the number multiplied by 8, which means the size of the variable in bits. One pitfall of this is the variable 10. A variable 10 was boolean in this case, which should be the size of 1 bit, since we can only store values from 0 to 1. But computers usually save it as 1 byte and will trace it as 1 byte, thus giving us the value of 8 bits. We'll see that when we actually print out the values. Next, let's get to typecasting. Typecasting allows us to basically convert values of certain data types into other data types when we need it. In the typecasting in a regular way, we'll just trace out an integer, but we give it a value which is actually a double, the 3.0. So the value of 3.0, the double value, will get interpreted as an integer, and our result will actually be 3. The second example of typecasting is called widening. In here we have a simple mathematical operation, 3 plus 2.85. However, the operator needs both values to be of the same data type. Well, but 3 is an integer and 2.85 is a double. So what are we gonna do about that? Well, since 3 or an integer is considered to be one of the most primitive values, it will automatically gets promoted to a value of higher level, in this case a double. Which means that instead of counting it as 3, it will counting it as 3.0, which is a double. Then we have double plus double, so the end result should be 5.85. The last example of typecasting that I will show you is the static cast. In here we have an integer variable of 30, and we'll be trying to cast it as a char, but we are casting a variable of 4 bytes and trying to put it in something that can only hold 1 byte, which can be potentially dangerous. So we're going to use the static cast command, which basically tells the compiler that we are doing something that can be potentially dangerous, and we know that it can be potentially dangerous, and we are fully aware of that we want to do it anyway. If we didn't use this command, the compiler would not be really happy and would probably notify us that something is really off. So in this case, it will print out the number 30 as a character, and it will relate it to the table of characters and print out the character that's there under the number 30. Well, that's all for typecasting. The last, we are going to display a number with at least 15 digits. In this case, we are going to use the command set precision, and we set it to 20, which means that our variable 8, which is a, let's see, variable 8 is a double, so we're gonna print this double with a precision of 20. So 20 digits will be printed out. Then the program waits for input, and after that terminates. So that's all for the explanation of the code, and now we will try to actually run the program to see if everything is working as intended. So let's run it. Cool. And yeah, so let's get to it. Well, we get our 10 variables. We get them printed out right here, no problem here. Then we get the size of all the variables in bytes, which we will then convert to bits. And of course, variable 10, which is a boolean, is displayed as 1 byte or saved as 1 byte, which is here considered to be 8 bits. But technically, the size of the boolean is only 1 bit. So this is a little bit maybe it might be a little misleading. Then our typecasting examples. As we said, a double 3.0 should be printed as 3. That's correct. Then our widening example is 3 plus 2.85. Well, 3 then gets promoted to a double, and we add 2 doubles together, which gives us the result of 5.85. And our last typecasting example, we have our integer, and we're trying to cast it as a char, even though it might be potentially dangerous if we were to include a value higher than 255. But we do it anyway, and we get this nice triangle as a result. And for our precision exercise, we set the precision to 20, and we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 digits. So everything apparently works as intended, and I hope to receive some nice points for this so I can actually pass programming. Thank you for watching, and see you next time.